Okay, good evening, everybody, and welcome to today's class. This is class 6, and we will be learning all about data structures today. All right, so as usual, keep yourself muted and keep your questions. They'll be attended to when it's time to accept questions. Okay, please pay attention to the class, avoid distractions so as not to pull others back while we move forward with our class. So today, guys, we'll be learning what we call data structures. Data structures, okay? Now, what are data structures? This is the building blocks of every information. This is the building block of every information you see. Now, we as human beings, we were made with a particular structure. We were formed, we got our shape with our particular structure. And as human beings, we call this our skeletal structure. Every animals in the world has that structure. Even plants, they have that structure. All right. So also data has its own structure. Okay. In order for you to arrange informations in any field that requires data, these informations are arranged with a given structure. And those are the structures we are going to be learning today. All right. Now, data structures in programming comes in 4 forms. All right. We have 4 kinds of data structures. We have the list, we have the tuple, we have the dictionary, and we have the set. I come again. We have the list, we have the tuple, we have the dictionary, and we have the set. Okay, guys. So we'll begin one by one by analyzing what these are and practicing them, learning how to use them. All right. And the differences between these structures. Now, all these structures you see are important, okay, when it comes to data. But there's one we call the baba of them, or the oga at the top. Okay, there's one we call the oga at the top, and we will get to see this one when we move ahead, because this one can consist of every other structure combined. That's why we call it the baba at the top, and that is the part of structure which is used to categorize and arrange every information and data we see worldwide. All right. So dissect them bit by bit, learn their workings, foundations, and how to implement them. Okay. So let's get to it, guys. Firstly, we'll be talking about the list. We're talking about the list. All right. Now, what is a list? A list is a collection of values that can be of the same data type or not. Take it as a list. A list, we know, is our normal arrangement of items, with any format or any way of arrangement we chose. The list, your grocery list is a list. Your shopping list is a list. Your academic list is a list. Maybe you made a list of your needs and your wants, or your to-do list, your daily activities. That is a list. A list can be a collection of any items, whether they are of the same type or not. All right. Now, a list is arranged sequentially, one after the other. Take, for example, you are going shopping to get groceries. You list out the things you need for your kitchen, for cooking, whichever meal you want to cook. Now, when you structure this list, if you are going to the shop to get groceries, to the market, you follow this list one after the other. That is how your list is, just a plain list of single items arranged sequentially. Okay. Now, a list is mutable. A list is mutable. Okay. A list is mutable. Now, when we say a list is mutable, it means it can be changed. It can be modified. It can be changed. It can be modified. Items can be removed. Items can be added. That's what we mean by a list is mutable. Like your grocery list, you can remove things that you don't need or things you can't afford. You can strike them off the list, which means you can modify it. You can even include new items in that list. All right, that's the essence of it being mutable. Okay, so please note this when you are working with list. All right, it is a collection of values of any data type, whether they are the same or not, can carry them. And items in that list can be changed in any order, in any format. You can change them when you feel like. Okay, so we are going to move ahead to learn how to use and implement this list. Now, what we have on our screen is 10 students in JSS2. We have their age and their name. This is the age. Sorry, this is the age, and this is the name of these 10 students. All right. So just take note of this because that's what we'll be using for our practice on list. So this is the age 57964586697. Then the name John, Cynthia, Omosede, Success, Faith, Kelly, Goodness, Adetola, Destiny, Rinze. All right. So these are the names we'll be working with. I just have to write them out before we proceed. Now, how do you identify a list in programming, in Python, most especially? How do you identify a list? A list is identified by square brackets, opened and closed. This is a list, square brackets. That's how you identify a list. All right. Now, this is an empty list because there are no values inside. When you declare a list, like I said, the list can contain any kinds of data type, any kinds of information, that string, boolean, integers or floats can be in your list, all separated by comma. Okay, so they can be your list. But where you see a square bracket without items inside, it is called an empty list. All right. So moving down, let's check for the type. What to know now? Like you can easily know when you see something like this. Now, this thing you are seeing, this bracket you are seeing, is assigned to a variable called empty. Okay. How to assign variables? We know that. How to assign items to variables. So this is an empty list assigned to a variable called empty. Now, let's check for the type of this to see what will come out. Now, when you run this, you're going to see class list, right? Is from the list. That's how you know this is a list. Type list. It gives you class as what? List. Okay. So that's how you check for any variables you have. Use the type to check for the data type. We learned this. Okay. You call the type function and you call the variable. It tells you the kind of data type. If it was an integer or whatever, or if you're checking for the data structure, if it's a list, a tuple, dictionary, or a set. So class type list means these are list declared. Empty variable is a what? List, because there are no items here. Right. Now, how do you put in items in a list? Now, when you carry a sheet of paper, it is blank, right? Then you give it a name. Grocery list. Grocery list. That's the name of your variable. Okay. That's what we have here. Grocery list. So, or maybe a list of students, like we are working with students in a class. You get a list or a register. It contains a list of the students. Okay, so maybe I give it a name, register or student information. That would be a variable name. Okay, but how do you put them in a list? Now, when you declare a list, each value is assigned and separated by a comma in square brackets. Now, for the first thing we created a variable called student age. Student age is equals to, open a square bracket, 5, 7, 9, 6, 4, 5, 8, 6, 9, 7. These are the informations present. They are separate informations because of the comma in between them. Okay, that tells us this is a list. 7 are in the 7, 5 days are all individual items separated by comma, all assigned to the variable name called student age to get their age. So when we print this using the print statement, as usual, we're going to get it like this, with the square brackets printing alongside it, right? And when you check for the type of this, let's check for the type. Let's check for the print. We open I'll put a type, go to the end, and I'll close the bracket. When I run this, we're going to get class list. All right, so it's a list because of the square bracket. That's how you identify a list. Okay, that's how you identify a list. Now, moving forward, we are going to also create, let me remove the type, sorry, and run it again. Yeah. So also I created a variable called student names. Now I've assigned the ages. Now I need to assign the names. All right. Now these variable student age is only carrying integer numbers. All right, because they're integer numbers. Also, the names is in strings because they are what? Alphabets, letters. So we know we categorize letters as strings. So that's why they are all in quotes and separated by individual comma. Now these names from John down to Arinze are 10 names for 10 different students, all assigned to the variable student names. Right. So when we print this, it comes out as a list having this student name. Right now, the way you put information in the list is the way it comes out when you print it. Okay, is the way it comes out, is the way it appears. All right, the way you put it is the way it appears. So that's how a list is, and items in each list are mutable. They can be changed, altered, removed, and you can do whatever you want to do with the list. Now, this is also a list with different data type. Like I said, a list can contain if values of different data types. Now, the first one we declared were of the same data types, data type integer, data type string. Now, this one we have has different data types included. Now we have the myvar, which is the variable name, assigned with the list having any, which is a string, carries 100, which is an integer, carries the name Bola, which is a string, carries 30.6, which is a float, carries true or false, which are Boolean values. All right, this is a list with different data type. Okay, now when you print this, it brings out the information same way it is written in the list. All right. Okay, so that's how you declare a list with items. You specify the items you want inside. All right. I hope we are getting the information, guys. So now, when you've declared this list, how do you get some particular items inside? All right. So when you say you declare a list and you want to go and get this, locate the list and find it and bring out a particular information from the list. Now, let's say from the student age we declared, maybe we want the age number 5 from the list. We want the program to bring just number 5 away from the list. We don't want the entire list. Okay. Now we use a method we call indexing. We use a method we call indexing in Python. Now, how does indexing work? Indexing in Python works with arithmetic numbers in square brackets. The square brackets here is not the same as the square bracket in a list. The square brackets you see here it means you are performing what we call an index. Okay. Now I'll break this down for you by explaining that our number system we know taught in school started from 1, excluding 0, started from 1 because 0 is nothing. 1 till when you want to stop. But in programming, in computer programming, or in any electronic field, engineering, numbers begin from 0. That's why we have 0 as our off, 1 as on, and every other number that comes along with 0 to 9. Then a combination of any number and 0 increases the number from 9 to 10, 11, and the likes. Repeating these numbers, repetition. Okay, that's how those numbers are formulated. Now, when it comes to indexing, please take note of these guys. When it comes to indexing, you index by the arrangement 0 to whatever number you have on your list. Now look at our list here, age. This is 5, 7, 9, and whatever. We have 10 items in this list. Now, because we have 10 items in this list, our indexing will begin from 0. The first item in the list has an index number of 0. The second item on the list has an index number of 1. The third item has an index number of 2. The fourth has an index number of 3, and so on and so forth till the last. Now, because we have 10 items on this list, the index number will be what? 9. The last item, the 10th item, its index number will be 9, beginning from 0. For those of us who were very good at mathematics in school, in high school, we understand this perfectly well. All right, when we are working with number systems, right? Even binaries. So we are taught all this. Now, it begins from 0. The first item is 0. When you are going backward, it's now 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have more numbers, you'll be going behind like that, okay? Now, counting it as 1, 2, 3, 4, 5, 7, 8, 9, 10 is just your normal counting of your number system. And we call that positioning. Okay, maybe it's in the first position, second position, or whatever. But indexing, you call it 0 index, 1 index, 2 index, till the last digit, which has the index subtracted. A minus, like 0 till the last 0 to 9, not 1 to 10, please. It is 0 to 9. That's indexing. Okay, indexing starts from 0, which is the first item on the list. I know why I'm specifying these, guys. Okay. Now, in order for you to access, let's say we want to get the first item on this list, we use the indexing method. Now, in order for the indexing method to work, like I did here, I assigned a variable name. Yes, it's good to assign variable name so that you won't get confused while working with your programming. So the first item, which is my variable name, I assigned student age. Now, indexing works with 0 in square brackets, but you need to tell the program where to locate that information that has the index number, which you are calling, which means you must call the variable name which has the information. Now, on this case, we are calling the name of the list, student underscore age. That's the name of the list we are calling, okay? Student underscore age is the name of the list we are calling. And after the student age, you put the square bracket and you index the number you want to get. So we want to get the first item on the list. So don't forget that the first item on the list is index number is 0. So this is first item is equals to student underscore age with the square bracket and 0 in it. Now, when we print first item, it's going to give us 5. It's not going to give us 0. It's not going to give us student age 0. No, it's going to give us the index value. The value of indexed 0. It goes to the variable, the list student age, which is here, gets the first item of the list 5, assigns it to the variable first name, and when you print it, it prints out what 5. That's how you index, guys. Okay, that's how you index. Now, let's say we want to get which value is in the fourth position. Sorry, which value is in the has the index number 4. We want to get the value that has the index number 4. Or let's say, okay, we want the value that has the index number 5. Let's do that. Now, if we want to get the value that has index number 5, I'm going to come and put index number 5. And when I run this, it's going to go back and get me the value here and will be 5. All right, the value here is 5 because this is index number 5. Okay, that's the sixth value. It's index number 5. So that's why it gave me 5. Okay. Let's say we want we want the value of index number 6. Let's run it. Now, this is how you get the information. Now, the value with index number 6 is what? 8. Now, if you count your list, 0, 1, 2, 3, 4, 5, 6, it has 8. So that's a way of indexing, for getting every item you want by knowing their index numbers, guys. Okay? That's how you get it. I hope you guys are understanding me. So if you have questions, just keep it down and we'll attend to the questions as we move on. Okay? Now, these are to get items in your list without the first item or every other item on your list. These are to get it. Okay, so I put this back at 0 and save it. Now, if you want to get the last item on the list, the last item on the list. Now, when we go to this place, this was the last item on the list. It is 7. 7 is the last item on the list. Okay, it's 7. Now, if you use our indexing, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the last item is 9. You must count it from 0 to whichever number you have as the last item, the size of your list. So 7 is the last item, and we want to get 7. And now for us to get 7, we're going to call the index number 9. Index number 9. So that's how to get the last item, index number 9. Okay, index number 9. Oh, sorry, let me run this again. Oh, sorry, I'm running the wrong my val. Oh, sorry. Let me change this. Sorry, guys, I used the wrong thing. Let me change this to student age. Sorry, student age. I was calling the wrong table. So I'm calling student age 9. Yeah, sorry, student age 9. So I was calling the wrong variable. It does not have values up to that. So student age 9 gives us the last age, which is 7 here. That's what we have here. Okay, 7 as the answer, because this is what the index number 9. Okay, that's how you get it. Now take for example, if you want to get that of the last item of your name, let's say the student name, just come and do let's do another one for first. Okay, let me do this one. Let's say last underscore item. I give this item 1 because I already have a last item. So I'll give this item 1. So I'll say to be equal to student underscore name. Then students underscore names. Let's check the names. Okay, so there are names. And I'm going to put a square bracket and put what's the last item? What's the name as the last item? So 1, 2, I have John 1, 2, 3, 4, 5. Faith, Kelly, Goodness, Adetola. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I have the index number of this will be 9. So as to get the last number, because it's 10 items I created. So I'll call these 9 as well. Then I'm going to print last item. I can just call last item without putting the print statement, guys. You can also call last item without putting the print statement. It's going to give me the value I need to arrange it. All right. So that's the name. So rather than including the print, I can just call the variable name because I already assigned values to it. Arrange it. So that's the last item we have. Okay. For the first item on the list, we can still do the same thing. Call the student and call age 0 or the index number of any of the items we need on the list. All right, that's how to get the first and the last item or any other items in the list, depending on how long or the size of your list. Okay. Also, there's what we call negative indexing. Now, all these ones we're doing 0, 9, 1, 2, 3, those are positive indexing. So as we have positive numbers, we have negative numbers. It also applies in indexing. You have positive indexing, which we just did, and we have the negative indexing. Now, the negative indexing works opposite. Okay, works counterwise. Now, let's say if the positive indexing works clockwise, the negative indexing works counterclockwise. Okay, opposite direction. So if you are using negative indexing, now don't forget that when you are doing your graph, your mapping, 0 is at the middle, then you do 1, 2, 3 forward. Now, if you're doing negative, you start from after the 0, -1, 2. There's no -0, it's -1. So to get the items on your list now, let's say let's let me use the age. Let's say this is 0, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the for the positive indexing. Now for the negative indexing, your last item will begin with -1. Coming backward, you have -2, -3, -4, -5, -6, -7, -8, -9, -10. That's for negative indexing. So please pay attention, guys, to avoid asking this question again. So if we're doing the negative indexing here, we're going to call to get the last item on our list. We're going to call the -1. Now, let's say let's work with this my var. This my var I have here. My var, now I have items named any 100 3.6 30.6 true false. Okay, those are my items on my list. Now, if I want to get the last item here using the negative indexing, I'm going to call -1, which I did here. Last item is equals to my var -1. Now, when I print this out, it's going to give me false. Now, don't forget that the last item on that list in positive index, if we count it, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Now, positive index, it is what? 5. Oh, number 5. No negative. Now, when you run this, you get what? False, because it is the value that is here. All right, this value here. Now, to get this same false, I'm going to put it -1. So this is useful when you have a very lengthy list and you don't know how long it is, and you don't know yet which is the last value or item, and you want to get the last item. Okay, maybe you have a long list given to you to check, and they say, okay, I need the last item to know. I've seen the first item, let me see the last item. And know maybe if I'm arranging alphabetically, let me see the last alphabet arrangement. So you use the -1 to get the last item of the list. No matter how long it is, it's good. You get it very faster than you using the positive indexing. Okay, that's the essence of you using this -1. Also, if you want to get the if you want to get the first item on this, do the negative indexing from the back. -1, -2, -3, -4, -5, -6. So if you come here, if I put sorry guys, I want to use the same thing. I don't want to type again. So I want to use the same thing. I'll put -6. -6 will get me the first item. So ignore this last item you're seeing, please. Ignore this. This first item, I'm just explaining. Now, the first item on the list is -6, which is what? Any. Now, don't forget that to get the first item, the positive index is what? 0. So when you print it as 0, it gives you what? Any. Okay, that's the first item on the list. All right, but negative indexing will be -6 because we only have 6 items in the list. So you have to count and assign this indexing while you are working. Okay, then use the program. You know the indexing offered, and then you call it in your program. Okay, so let's take this out as -1 to get the last item. Very quick and easy. Like I said, this is useful when you have a very lengthy list and you don't know how long it is and you want to get the last item. Use -1, you get the last item. All right, guys. So that's it. Now, like I said, lists are mutable, so you can change values within the list. Okay, you can change values within the list. And another way to change values, you just call the variable where you want to change the values. You must call the variable name and the index number which you want to change its value, because you only get this information using indexing. So you can change the item of a list using what? Indexing. How do you do it? You call the variable that has the information you want, call the index number of the information you want to change, and then assign a new information to it. All right, now the first item we have on our list is what? Any. Okay, that's any. Now, in order for us to change any, we want to put Moses in any. I have to call my var, which is the variable name, which is this. My var, which is this variable name. I have to call it because what has any. After calling it, I'm going to index the number of any, which is 0. Then I'm going to assign Moses to it. All right, so I'm changing the first item and the last item. Now, to change the last item on that list, the last item we have was false. So I want to change it to 0. In order for me to do that, I still have to call the variable name, call the index number. Now I'm using negative indexing to locate it rather than using 5. I'm going to use negative indexing, which is faster because I might not know how long it is, for example, but I just want to change the last item. So I'm changing last item first. I want to put 0 to it. So call the variable name that has it, call the index number, and then assign 0 to it. So let's run this and then print my val. Now all we can see here now, Moses 100, Moses 100 Bola 3.0 through 0. Now the one we had initially was any 100 Bola 3.0 true and false. But changing it, we have Moses 100 Bola 30.6 true and 0. All right, guys. So that's how you change information with a list using indexing. So the list is mutable, items can be changed whichever way you want. All right. So um also, let's say we want to get the items on the list. We can also index them when we don't know the uh index value. All right. You can also index. Also index when we don't know the index value. Let's move down. Now, let's say we want to get on this list now, we want to get Moses to Bola, all right? Moses to Bola. We don't want to see 30.6 true or 0, but we want Moses to Bola, all right? Now, we use what we call slicing. We call it slicing in indexing. So you slice, all right? How do you slice? By including a colon to whatever you're doing. So let me create a new code and using slicing. So I'm going to comment this. So this is using slicing method to get items from a list. Okay, to get items from a list. So using what we call the slicing method. Now, in order for me to do that, I'm going to slice by, I can use the print. I can instead of just call the items. So I'm going to call my var, sorry, my underscore var. So you must call your variable name the way you declare it, otherwise I'm going to have errors. Now my underscore var is not equal to, sorry, my underscore var, I'm going to put my square bracket. Then I'm going to slice. All right. I'm going to slice. How do I slice? Let's say I want to get from, like I said, I want to get from Moses to Bola. Now Moses has an index of 0. Bola has an index of 2. So I'm going to slice using the index number 0:2, which tells the program, get me information from the first item to the third item on the list using the index number. So I'm going to do 0:2. All right. So this is how you slice. This is how you use slicing. Okay. Let me include the print statement here. Let me include the print so that it just look more better. I'm going to print. Go to the end. I'm going to print. All right. So let me print this and let's see the information we have. So printing this, you can see we have Moses, 100. All right. Now, somebody will ask me, oh, sir, why are we getting 100 instead of Bola? Yes, because when we are working with range the other day, I explained that range omits the last numbers. Also, slicing omits the last number. It stops at 2. So if we want to get Bola, we are going to increase it by saying what? 3. That means the item with the position with the index number 3 won't be given, but will just stop here in between it. Okay, I used 2, so it did not give me Bola because Bola is 2. It stops at 2. It does not give you the information. So if I want to get from Moses to Bola, I'm going to use 0 to what? 3. Now this is how to what? Slice. When I run this, I'm going to see Moses 100 Bola. Are we together? This is how we slice. Okay, now if you want to slice from 30.6 to 0, you just come and change the values, count the index number 1, 0, 1, 2, 3. So I'm going to say from 3 to, what's the last number? 3, 0, 1, 2, 3, 4, 5. Now if I put 5 here, I won't get 0. It's going to give me 3.0, 30.6 and true. Because like I said, indexing and range omits the last number. That's what they use as their start and stop. Okay, that's what they're telling you to do, start and stop. When we're doing range, we did this. So start and stop, that's what we're telling you to do with slicing. All right, so if I want to get 0 now, I need to increase my number as 6. And when I run this, it's going to give me 0. Okay, I need to increase it to 6 so that it will stop after the 0 rather than before the 0 if I use 5. Okay, that's what slicing does. Now, in order for us to slice again, let's say we don't know the last number, but we know the first number. I want to get from the first to the last, but we don't know the last number. All we have to do is specify the start point, which is 0, and then we are going to omit the end point, make it blank, don't put anything after the colon. That means that you're telling the program to start at index number 0 and print till the end, whichever value you have at the end, print everything for me. This is how you slice. Okay, so I run this. As you can see, it's giving me Moses 100, Bola 30.6, true and 0, because I specified my start point as 0 and I said slice and give me information till the end of it. That's how we got this. Okay, that's how we got this. Now, if I don't know the beginning, or I don't want to get the beginning, I can omit it. Okay, let's say I want to get the third item of the list. I want to get from the beginning to Bola. Now we count 0, 1, 2. Now to get Bola, we must increase it by 3. Okay, so I'm omitting the start point and I'm putting the end point. When I run this, it gives me what? From Moses to what? Bola. I don't need to specify the start point. Okay, so you can play along with the code. Also, I can decide not to put anything in my slicing. It prints everything, whichever way whichever place the list started from and to the end. When you run this, it prints everything for you. Okay, even if I omit items in between the colon, look at it. There's no item at the front. There's no item at the back. So it starts from the beginning, whichever way the beginning is, and wherever the ending is, it goes and gets every value. That's how we print everything. Okay, using slicing too. Okay, guys. So let's grab this information, and it is very, very important when we are working with data. Okay, you can slice through any data structure. Okay, slicing works for every one of them. Okay, guys. So sorry, I'm going to exclude this. This is not part of what I want. So I'm going to remove this. I'm going to delete some notebooks. Yeah. These were all part of practice, guys. So I don't need them. I'll remove them for your class. I just use them to practice on my end. Okay, so now how do you know the size of a list? Now in the previous class, some of you saw me using len, and some of you might be asking, what does len do? What does this do? What does this do? Now len is for you to know the size of a list, the length of a list. Okay, you want to know the size. Now what this gives you is a figure. It does not give you the entire everything on the list, but it gives you a figure which shows the size of the list after it's counting. So len is a function that is used to return the number of items in a container in a variable in a list. Now you can use this for any variables to know the items it has. There's 1 or 2. You can use it to get for list to know which it has. So I assigned it as size. So use the L function, my var, and I'm calling the variable I want to check for the length. Now when I run this as size, look at it, gives me the number 6 because the items in our list was 6. Now if I use the other list age, student age, or let's say student name, we use student age a lot, student names. When I use student names, I want to check for the size. I run it, I'm going to get 10 because that's the number of items or student names in our list, guys. Okay, so I'm going to move forward from that. That's how you check for the length of the list. Now there are methods you can perform on a list. Okay, like I said, list is mutable, can be changed, can be modified. So there are things you can perform, there are methods you can perform. Now we have the dot append method, the dot extend, the dot copy, the dot pop, the dot remove, the dot sort, dot clear, dot count, dot insert. These are the methods you can perform on a list. Now these are used to modify a list. Okay, these are used to modify a list. All right. Now let's say now this is our list again. This is our list which I already created before. So I'm not going to run this. I'll leave it. Now let's say we want to add our list. We have now student names. This is what we have as our student names. John, Cynthia, and Mercedes. Now we have 10 names in this list. Let's say we want to add something new, a new name or a new age or something new in our list. All right, we can use the dot append, which means add this thing, append. Now, what does append do? When you use the dot append, it adds information. We have the new information you are putting it. Now, when you call the student name, call the variable name where you want to put in the values, use the dot append method. Use the dot append method. The append method, which comes with a bracket like our print. Then inside the bracket, you specify what you want to add. Okay, now I want to add Grace to our student names. So when I run this, Grace will be added to student names. Now when I print student names now let me first of all print. Okay, no, let me print student names here now. Let me print our student names. So I'm going to print our student names. Now when I print student names, Grace has been added. Now look at it. Grace has been added at the end of our list. Okay, it always adds at the end of our list. So Grace was not there initially because when I run this, and I run this again, watch, Grace is not here. It's only stopped at Irinze. But when I do the append method, Grace was added. When I run this again, Grace has been added. Look at it. After Irinze, Grace has been added. That's how to use the append method. Now you can use the append method to add in multiple items in the list. Okay, you can use it to add in multiple items in the list, right? Which you did here too. Use that to append and add multiple items in the list. Okay. Now the next method is, sorry, I want to give you the difference between this and the insert. Now the append method adds information at the end, always at the end. Okay, that's where it puts the new information you are adding to a list. But let's say you want to add Grace now or something else in between the list. You want to add it somewhere in the list. Okay, let me change this as Michael. I don't want to put on Mercedes. Let me use Mike here, or Mike. Let me use Mike. Now let's say you want to specify the location where you want to put it. Maybe you want to put it at the middle or somewhere. You don't use the append because the append only adds at the end. But you can use the insert and then you specify the location where you want to put it. Now this is how to work. Student underscore names dot insert. Then open a bracket. You put the position, which is 4. Now I'm using 4 because using the index number 0, 1, 2, 3. I'm using 4. So I want to put it in the 4th place. I want to put Mike inside my list, not at the end. So when I run this, it has added. So let me print it. Let me print student names. Let me just call student names. I don't need to be putting the print again. Student names. Now when I call student names here, I'm going to get everything run. Now look at it. John, look at Mike. Mike is after success. Okay, after success. That means after the 4th link, put Mike. Okay, let me use the print so that it's going to come out very fine. Use the print. So this is why we sometimes like using print so that it makes our list a straight line. So let me run this so that it's going to print it in straight line. Yeah. So John, City, and Mercedes success, Mike. Now in our first list, Mike wasn't there. Look at it. John, City, and Mercedes success, Faith. But we said after success, put in Mike at the 4th position. Now 0. Listen, this is 0, 1, 2, 3. The 4th position was Faith, but we're telling it put Mike now in the 4th position. It does not mean replace Faith. I'm using the insert, so I'm not replacing Faith. I'm not using the assignment. I'm only telling it put Mike there and move Faith forward to the next index number. So I'm increasing the size of my list by putting Mike. That's the difference between the insert and the dot append method. The append adds at the end. The insert, you can use it to add anywhere you specify the location first, which I did. Okay, guys. So that's it. So now let's say you want to extend. Now, what does extend mean? Dot extend is also a way to add information into our list. Okay. Now they append at the end. Insert can be used to add anywhere. Now the extend means increase the list by using this information. You can extend with a new list, guys. That's when you use dot extend. Okay. The answers I'm explaining these informations for you because I won't run through them again. Only few when we get for that list. So it's important we know these things and how to use them well, because not all these tools can be used in some of these data structures. Some have limitations too, but it's best we learn them at hand. Now, I'm creating a new variable called student name 2. Now, I want to add this information now into the first student name we had. Now, how will I do that? Let me first of all create this. I run it by creating it. Now, after running, I've created student names 2, Bright, David, Joy, Goswell. We don't have it here, please. So I want to add it to this place. Now, I won't use dot append here because this is already a list. So in order for me to make it work, I'm going to use dot extend method, which means take the first list, which already has name, student name, and extend it, increase it by adding the list in student name 2, Bright, David, Joy, Goswell. So when I run this program, it has run. Now let us print student names, which is the original student name we have here. So when I print it again, watch, guys. John, Cynthia, Omosede, Success, Mike, Faith, Kelly, Goodness, Zetela, Destiny, Arinze. After Arinze, we have Grace. Now, because I'm extending, Bright is now coming in. Bright, David, Joy, Goswell. Now, the Bright, David, Joy, Goswell you are seeing here is the one I just created here. So that name 2. Okay, that's what it added to the end of this. The initial list stopped at Grace. Yeah, but I use the dot extend to extend this list by creating a new list and extending with this structure of code, this line of code dot extend. Then I call the list which I want to extend with. Okay, guys. So that's how to use the extend to add the extend, the append, insert to add informations list. Now, dot copy is used to copy an existing list or an existing item into a new variable. Okay, that's how you do dot copy. Let's say I do student name 3. I want to copy every information in student name to student name 3. I use the dot copy. Okay. How I do, I'll just call student name dot copy. I specify the one I want. Okay, by assigning variables. Now that works like this. Let me create student name 4 so that we know what dot copy. Let me do here. Let's say hashtag copy. I know I did it somewhere down, so let me just do it here. Hashtag copy. This is how to copy. So I'm going to create this new one. I'll say student name, student underscore names. I'll call this 4. Then I'll say students and names 4 is equal to student names, student underscore names dot copy. All right, so this is the dot copy method. This is how you use it. You take it dot copy, and what I'm telling the program is that create a new variable called student names 4. Then take the informations of student names, copy everything, and assign it to student name 4. So when I run this, it's going to work. So it's copying, then it's done. Now when I come down and I include print student name, let me put my bracket. So student name 4, yeah, that's what I have. So print student name 4. When I print this, let me run it again. So after copying it, the information student names, assign it to student name 4. Look at it. We have Johnson, Thomas, the Success, Mike, Faith, down to Cosby, which is the same as this. All right, that's how you do dot copy. Okay, that's how you copy information to a new variable, and you still have the old one. Nothing changes. I can still even print the old one here. But okay, because I did not alter, I only copied. Right now, dot pop. Dot pop is used to remove items in the list. It's used to remove items in the list. Okay. You have the dot pop. Let me just run through the explanations a bit. Now we have the dot pop. Dot pop is used to remove items in a list. Now, when you specify dot pop, you need to call what you want to remove. Otherwise, it removes anything it can lay its hands on. It can remove the last item from the list or the first item. It just depends on how it works. Mostly, it removes the last item from the list. The last one you just created removes it. Okay. This works like first last in first out. So that's what the pop does here. Unless you specify an index number, which you want to pump. Unless you specify what you want to pump. Okay. Now, dot clear means to clear a list. Okay, to clear it. Let's just move down so that we learn about all this. Then we'll move forward to learning others. All right, so moving down, let's see. Dot pop now. Look at it. Dot pop. Student names underscore student underscore names dot pop. Okay. Now we have 16 items in the list already. So I want to pop something. Let me just run this. Let's pop it. Now, look at what it popped, Ghostly. Like I said, pops the last thing you just added. And it prints it out. It pops it, prints it out, and discards it. All right. The last thing in our student name is what? Ghostly. So pop the last item. Now, one thing you can do when using the pop, you can assign whatever variables you are popping, you can assign it to a new place so that when you need it, you can still get it back. But when you use dot pop, it pops the last thing, unless you specify what you want to pop. Now look at here now. I'm assigning what it popped to a new variable. So I have to go and run this back so that it's going to save. Let me run these. Let me run this from the beginning. Run. Yes, student name has been saved. Let me run the extend. Let me run the insert. Okay, I'll run the append. I'll run the insert. I'm just running it back so that I'll get all my informations. And let me print this. I think I have. Yeah, okay, Grace is here. So let me do the dot extend with this and print this. I know I have Goswe here. Yeah, Goswe is here back. So when you pop, okay, it pops the last item and throws it away. But you have the ability to save whatever you're popping somewhere so that you can still call it, which is what I'm doing in the next line of code. Look at it. I declare the variable latest underscore pop, then I use the same pop and I run it. It pops and saves Goswe in latest what? Pop. So when I print latest pop, so when I do print latest, when I print call latest pop, sorry, latest pop. Now when I print latest pop, my variable I popped is still here. All right, is what I popped is still here. I can later append it to that place. So whatever I popped is here. Look at it. So it did not throw it away like this initial one would do. So when you assign it, it saves. That's why I use the pop. All right. So this student name. Now when I print student name, because I've popped something out, look at it. I popped. So Goswe is no longer here. It's not ending with joy instead of Goswe. Not ending with joy. So that's to show what I popped. Okay. Now, like I said, you can pop by specifying. You can pop by specifying the index number where you want to pop. Okay. Yeah, I specified the index number 13. Yeah, I just popped without specifying, and it popped the last item. So you can specify what you want to pop. Let's say I want to pop John. Okay, I want to pop John. So let me put index number 0. I want to pop John, but let me assign this to new pop so that it will be saved. So I got this new underscore pop. I'll assign it so that I want to pop with the first item. So I'm going to run this. So it has run, it has popped new pop. So when I run this back, what John is no longer here. Okay, that's how you pop by specifying what you want to pop. Call the index number and you pop it. Okay, guys. So that's for that. Please ignore this, ignore this code, ignore this one. Let me comment this code. This code. Okay. All right. So the remove. You can use the remove. Now, this is the difference between the pop and the remove. The remove also is used to remove exclude item from a list, same as the pop to delete any item from the list. Okay. Now, the remove, when you want to use the pop without the index number, it pops the last item, unless you specify the index number of what you want to pop. With the remove, you can just write whatever you want to pop as it is in the list. Now, this is almost the which is in our list. Okay, here, look at it. Now, because I want to remove it, I use the remove to remove it. I'll just say remove a message. I can, instead of, let's say I don't know the index number, I can't tell where it is. I can't tell where the index number is. Now, when you know the index number, just use pop. But if you can't tell where the index number is, but you know the name is there, you want to remove it, or something is there, you want to remove it, just call the thing the way it is. Here I can say student names the remove, and I call almost a day. So it's going to remove what? It's going to remove almost a day from the list. Okay. So let's move on. Now, the dot delete is also used to exclude items from the list. Now, you use delete student names. Now, this delete is a function, right? That's why it's here. It's a function. You said you call it delete from student names the item with index number 11. Here, you must specify the index number 11. Okay, that's what the delete does. Okay, now you can also delete by using slicing. You can also pop by using that. So delete using slicing. Look at it. I did not specify. Now this is how to delete the entire list. So using slicing, delete student name. You don't specify the beginning, don't specify the end. It's going to remove everything from the list straight away. All right. That's what the delete does. You cannot use the delete to save. It's only the remove and the pop you can use by assigning it to a new variable. But the delete, you cannot use it. Whatever it deletes goes off. Bye bye. That's it. Okay. Also, declare. Look at it. Student name dot clear. Clear is a method to wipe off a list. All right. Student names dot clear. So you don't specify anything in the clear, just blank. So when you say student names are clear, it wipes off everything in the list. When you're using delete to wipe off everything, specify what you want to wipe, or you put it empty using slicing, it removes everything. If you want to remove everything without the delete, use the dot clear method, but nothing must be in the bracket. So that wipes off your entire list. That's how to clear. All right, guys. So that's for clear. Let me put it here. Let me say to clear. Okay, to clear. All right, easy to clear. All right. So ignore this. Thank you. Now count. To count. What does count do? What does count do to count? What does count do? Let me put this out. Sorry. Count. Now we use the length function length to get the length of our list. Okay, the entire length of our list. Now, what you use the count to do? What you use the count to do is to count how many times an item appears on a list. Is to count how many times an item appears on the list. So when you want to count, you count and you write the name. Let's say we don't know how many times or most of these in our list. We don't know. Well, let's say we accidentally added the most of it twice, or you're giving data to check. What do you want to see in the data? What do you want to count? You want to know how many times this information is present on that list. If it was a mistake or if it was just there on purpose. You use the count. Now you call the variable name dot count, and then you call the item you want to count. Just write out the name or whatever you want to write to count. Okay, that's how you use to count. Now it's telling us one because it's only once. Most of these in our list. Look at it. It's only once. Most of these on our list. Let's say let me name this student name 5, and then let me add a most a day somewhere here. Let me add almost a day here. Let me say quote almost a day. Almost a day. Okay, so let me run this. student name 5, and I'll come here and call student name 5, and then I'll count it. Now watch, I'm gonna count. Watch how many times most of this is gonna appear. Twice, because I added it twice. 1, 2. So that's how I use the count. Okay, showing twice. Right, guys? So that's how I use the count. Okay, so ignore this, ignore this. Good. So the next thing, we spoke about append method. Now, sorting on a list. Sorting on a list. You can sort on a list. Okay. Now, when we talk about sorting, sorting is an arrangement, right? It's how you arrange on a list, or any data. We call that sorting. Now, we call the method dot sort to sort a list. Sort method. Now, yeah, I'm declaring my var 2010 5 17 13 18. I'm declaring it anyhow. No order of precedence, no order of arrangement. Right. So in order for me to sort it, I will say my var dot two, my var two, that is my underscore var two dot sort. This is the sort method. Dot sort. Then I put the bracket. So when I run print this, let me comment this first. Let me comment this and run this first so that you see the difference. Now, this was how it is when I specify the list 2010 5 17 13 18. Okay, it came out the way I write it. Now let's say you want to arrange it alphabetical order or order of hierarchy. So all I'm going to do is put the dot sort method. When I run this, watch, it's going to arrange it from smallest to highest. Okay, that's why I use the dot sort method. Now the next thing is the sorted function. Now we have the dot sort, we have the sorted. Now the sort method is used to sort a variable directly. Okay, why the dot sorted is used to sort a variable and assign that sorted variable to that sorted values to a new different variable, and it does not affect the original one. Because what you're doing is like you're creating a copy, sort it, and carry that copy you have sorted, paste it in a new variable. That's how the sorted works. All right. So the dot sort can be used directly to sort a variable and save it. The sorted can be used to sort a variable, carry the sorted variable, and put it in a new list. So that's why we have my var2. I declared it here again. Now when I print it, it's coming like this, 2010 like this. But including the sorted, now I declared a new variable. Sorted list is equals to, I called sorted. Look at it. I call it sorted in the bracket, and I specify what the variable I want to sort. Look at it. It's just like using the print. Then in brackets, it puts here what you want to print. But here you're using sorted, which is a function. You put now this sorted is a method dot sort, but this sorted is a function. So I call it sorted. Then I put my variable 2 inside, and I close it. Okay, guys. So that's how I use the sorted. Now when I run this, I print the sorted list. It's going to get 5, 8, 10, 13, 17, 20. Okay, going to get it. So that's why I use the sorted and sort. So when I print my var2, watch, my var2 is still having the way I declared it here. Look at it, the way I declared it here. That's what it's still looking like. But this one that is arranged now is sorted list, not var2, because I sorted it using the sorted method, the sorted function. So I'm copying it, sorting it, and putting it in sorted list, which is this. But my original value still remains intact. All right. So you can reverse the list. You can reverse a list. All right. So you can reverse a list. Maybe after sorting. Now I sorted because when you sort is going to sort from smallest to highest or ascending order. But including the reverse, when you call the reverse now, reverse is a function you can either put on or put off. When you use the sorted function, automatically it is sorting alphabetically. All right. But when you put reverse is equals to true, which is done here, it means after sorting alphabetically, turn it the other way. After sorting ascending order, turn it to descending order, reverse it. Okay. So here now we have my var2, which is 20, 10, 5, 13. Now, when I sort this now, I call it reverse. Watch. It's going to give me 20, 17, 13, 10, which is different from 5, 18, 8, 10. So it's reversing this and putting it here. All right. So that's what the reverse function does. Okay, guys. Better to use the reverse. So I've talked about adding a list, how to extend, and how to delete. We've done these ones. So that's all for list, guys. That's all for list. Then yeah, that's all for list. Okay. Now there's what we call list comprehension. Just take note of this, guys. Mostly we don't use it, but sometimes we use it. There's what we call list comprehension. Now, when you create a function, for example, now here we are using the for loop and the if statement to create numbers, to generate numbers. Okay, we're using it to generate numbers here. Odd numbers is equals to an empty space. So this is a list. We declare a list called odd numbers. Then we use the for and range to generate random numbers from random 20 numbers from 1 to 20. All right. Then we include the if statement. Said if x is not equals to 0 and x modulus 2, we are talking modulus 2 is, and x what modulus 2 is equal to 0, then append the value of x into odd numbers. So when it prints out, generated these numbers, this range from 1 to 20, from 0 to 20, sorry, rather, like 0 to 19, then it's going to check the condition if it is true. If the condition is true, because we're using the AND logical operator here, if it is true, it's going to append. Otherwise, it won't. Right? So this is what lists. This is how we do normal writing of codes. Okay, this is how we write codes. Now, what we talk about list comprehension. List comprehension is rather than you breaking it like this, half, indenting it, putting using indentation, you can just write them in a straight line, which is this, which is just did here. So all this we did was just to right. Now when I print odd numbers, look at it. It's going to generate 2, 4, 6, 8, 10. So I'm printing even numbers instead of odd because I'm using this function. So don't get confused about this, guys. Just ignore it. So as you can see, this was how the code was written in different line. Line 1, line space, line 2, line 3, line 4, line 5, including this one. So everything is line 6. 1, 2, 3, 4, 5, 6. 6 lines. Put them in one line, which you see here. Can you hear me now, guys? Hello, can you hear me? Sorry, it's so bad. I didn't know you guys were not hearing me. I was moving ahead with my class and nobody could say anything on the group chat. I was even expecting somebody. I was not even on the group chat looking at it, and I didn't get any message that my mic isn't working. So I'm sorry for that. What was the last thing you guys heard me say? What was the last thing? Let me give room for one person to talk. Yeah, you've messaged me. Yeah, sorry, I wasn't looking at the screen. I was sharing. I was actually working on my collab, as you can see. I just said let me come back to here and see if you guys are with me. And fortunately, you get my mic has been on. So, which part do you guys hear me last? What was the last part you guys heard me say? What was the last thing? Somebody speak up. What's the last?
Somebody speak up.
So we're about to enter tuples. The
Oh,
last
good.
one.
You're on track. You're on track. Oh, I thought it was what I've been teaching so far. So we're on track. So there's no cause for alarms. Oh, we want to enter tuple. So there's no cause for alarms, all right? So let me share the attendance for you guys so that you go with your attendance and then we go through what tuple is and we attend to questions. Thank you very much for following up to this point. So the attendance has been shared on the chart. Please fill your attendance. It's also pinned. So don't tell me, sir, attendance in the next 30 minutes. I'm not going to answer anybody, please. So it has been sent to the group chat. Do a copy it and send it all over so that as we see. For me, I won't attend to anybody who says, sir, I don't see it. For those of you who like leaving the class, it's your choice. So it's pinned to the group. So when you come back in, it is there. All right. So fill your attendance while we move on to the class. And please also pay attention while the class is going on for the few times we have left. Okay, thank you very much, guys. So we're moving on to tuple. We're moving on to tuple. Now, listen to this, guys. For a list, you can perform whatever functions you want to perform on the list. Yes, it is mutable. You can do whatever you want to do with it. And you identify a list by what? Square brackets. That's how you identify a list. Now, when it comes to tuple, a tuple is also a collection of data or values that can be of the same data type or not, like a list, but tuple is not mutable. It is not like a list that you can change items. In tuple, you cannot change anything inside. Once it is created, its values are constant that cannot be changed. Okay. Now, tuples are mostly useful when you want to represent a collection of items which you don't want anybody to tamper with. You don't want them to be modified, like your passwords, your username. All those things are saved as tuples by the programming of whichever application you are using. So that's what tuples are used for. Okay. Example are database records, coordinates, map coordinates, then functions, which are returning any value. When you learn functions, all these things are created and saved as a tuple. So once you create a tuple can have different data type of values. But once these functions are created, you cannot change them. So most of the functions we learned in list cannot be used in tuple. You can decide to try it out. You will get some errors. Not all will work. Okay. Anyone that needs to modify the list will not work. Yes, if you want to delete, you can delete. If you want to clear, you can clear. Or there are some modifications you cannot do in tuple. Okay, guys. Now, how do you identify a tuple? A tuple is identified with our normal brace, our normal round brackets. List is identified with square brackets. Tuple is identified with round brackets. Now, like we did in list, empty is equals to round bracket. So when we print the type, it's what? Class tuple. So always check for the type of any variable or you are using to work. So class tuple, this is how you identify it. Now, when you are putting values into a list, you separate them with comma. All right. So also in tuple, you separate them with comma. Now, in this place, we specified one item in the tuple. There was no comma, but it is what? A tuple because of the round brackets. All right. It's not without the bracket, it's just a variable that has an integer value of 2. But with the bracket, it is a tuple which has integer values. All right. Now, if you are specifying multiple items, like in list, you must separate them with a comma, which is this. So that's what we did. Class tuple. New example is equals to 2, 3, 4, 5, 6, 90 tuple. All right. Now, another thing we can do with tuple is this. You can also assign tuple without the brackets, but the comma must be present. You can assign tuple without the brackets, but that comma, because the comma itself makes the tuple unique aside from the round bracket. It is not like list, which the bracket must be there. If you declare any variable, like you want to declare a list, you omit the bracket and you put multiple items and use comma to convert it to a tuple. The program will take it as a tuple and save it as a tuple. So that's why it is unique. You can, this now we are declaring values, same way we did here, but we are not using the bracket. So when you run this and print the type, it still be what? A tuple. Because of the comma. The comma is unique to each and every item. Now, in this place, we declare the single value in the bracket. We can also declare a single value without the bracket, but the comma must be there. Look at this. Here, no brackets, there's comma. But here, there's no bracket, but the comma must be there. If I just remove this comma now and I run it, this will just be like an integer value assigned to a variable in my top. It won't be, let me run it. Let me put type here and run it. Look at the type. Let me open the bracket. I'll put type. Then let me close this so that you see what I'm talking about. Now, without the comma, if I run this, watch, it's going to be an integer, int. But when I put the comma, watch what will happen. If I run it, look at it, tuple. All right. So it is unique to them. You must understand all this. All right. So these are your assign values with or without brackets in a tuple. Now, if you want to access list, you want to access items in a tuple can also have different data types, please. That's what we did here. I've already explained that. Now, if you want to access items in a tuple, you can also do that. The way you access items in a list using index, you use it in a tuple too. Using what? Index. That's how you access items in a tuple and a list. So know their index number, please. 0, 1, 2, 3, 4, 5, 6, 7. It applies both in both ways, both in list, both in tuple. Indexing this way applies. All right. So in order for you to access them, let me run this. So this is a tuple. I want to access the second item. I call the name of the tuple and then square bracket. Now, like I told you in list, this square bracket you are seeing is not the same as the square bracket in list. This is for indexing. So it must be included in every kind of data structure you are trying to index. Even in set, even in dictionary, you must use the square bracket as an index criteria. So my top square bracket 2, when I run it, it's going to give me what? The value 4, because that's what has the index number 2. So it's the same way. All right. So ignore this. Ignore this. Also, you can use slicing too. Sorry, something. Also, the same way you use slicing in list, you can use slicing in tuple. All right. You can also use slicing in what? Tuple. So this is the def function. Like I said, there's some things you cannot do in tuple. Look at it. I cannot delete any item in the tuple. I can't. As I said, some functions will not work. It is immutable. You can try them. Some functions will not work, while some will work. Okay, that's what we just have here. All right, guys. So I just say let me try this so that you see this is the delete function. So you can try any other ones if you want. So let me delete this so that I want to make my code look somehow. Now, like I said, if you want to change any values, it will raise an error. So I'm not going to run this because if I run this, it's going to change it. Cause an error. So You cannot change values in an item in a of a tuple. It's immutable. It is permanent. All right, which is that. So okay, let's leave this. You can use the indexing. So my tuple dot count. Yes, you can count as well in tuple. You can do the counting. Now this one is counting the value 3. Now, when we were counting the most a day in list, it shows us 1. Then I added another one. It shows us 2. Now this one is in the tuple. You can count. This counting is not mean it does not tell the program you are changing it. But anything that involves you changing cannot work. All right. If you want to change the tuple, it cannot work. You can count. You can index. You can find. You can search. Whatever you want to do with it, but you cannot change its values. All right, that's what differentiates a tuple from a list. A tuple is in special cases too. Passwords, usernames, all those are crypto wallets, everything. These are all created with tuples. That's why nobody has the same thing. It's unique. Okay. Now, sizes of tuples. Yes, you can check for the size. You can count the number of occurrences like we just did in lists. Okay, so please ignore these ones. All right, so tuple packing and unpacking. Let's just understand what this means. Now, tuple packing and unpacking. This is used. This is used when you create a tuple without a bracket. It is called tuple packing. Okay, when you create it without a bracket, it's called tuple packing. And the same way we created the first ones without brackets is the same way we are doing this one. Sorry. Same way we are doing this one. Okay. Once you run this, the program sees this is a tuple. It saves it. Look at it. When I run it, it's going to save it and print it in the round bracket. Look at the round bracket here. It was not here initially, but it came here. This is a what? A tuple. Okay, guys. Now you can also pack by assigning values. Look at this. Look at this, guys. You see the way I packed this? Yeah. 1, 2, 3. Now here I'm reversing it. X, Y, Z. Now what I'm simply telling the program to do is that pack tuple as 1, 2, 3. So assign 1 to X, 2 to Y, 3 to Z. That's why I said X, Y, Z. These are different variables, multiple variables. I'm assigning multiple values in them. So if I run this, it's going to print 1, 2, 3 because 1 is X, 2 is assigned to Y, 3 is assigned to Z. Okay, this is how you unpack. This is how you pack. You pack by declaring without the brackets. You unpack by using that values you declared, assign them to 3 different, you separate them. This is just separation. That's what I mean by unpacking. Okay, that's what I mean by unpacking. Then also we can have nested tuple, right? So you have the nested the if nested if inside if nested if else. You also have nested loops, for loops and while loop. You also have nested tuple. Nested tuple means a tuple inside a tuple. Look at this. This is one tuple. Watch the brackets. This is one tuple. Or when you open, you must close. This is another tuple. This is another tuple. So we have 4 tuples all in one tuple called my nested tuple. So when you run this, you're going to have these 4 different tuples. Okay. You can also have nested list too. Yeah, no, we didn't do that. You can also have nested list. So this is what nested tuple. Also, a list can also be included in a tuple. Look at it. 10 is a tuple. 4, 1. Look at the brackets, square brackets. This is a list. Square bracket, this is a list. Okay, guys? So you can also include the list in the tuple. All right? So this is how you create a list in the tuple. Just include them, then brace them in round brackets. So everything here uniquely is what? A tuple, guys. All right? So this is also an example. Let me run this. So look at it. When you print it, you have it like this, same way you declared. 10, 4, 1, which is a list, 6, 2, which is a list, all inside the tuple 10 for this. Now, if you're indexing this, this is 0, this is 1. This whole entire square bracket is one item. This is 0, this is 1. This other one is what? 2. Don't forget, item 2 is a list. Item 1 is a index 1 is a list. Index 2 is a list. Generally, they are in what? A tuple. So you can create a list and then, oh, I don't want this list to be changed. Save it in a tuple. Nobody will change it for you. So that's how you do that. Okay, this is a nested list. Like I said, we can have a list inside a list. So this is a nested list. Sorry, I was playing around with the code, so it's somewhat scattered. Okay, so okay, this was me trying to, I was trying to change values in it. Okay, I was trying to change values. Now, if I want to index this, listen up, guys. If I want to index this, we call that indexing. Okay, so let me index this. Now, this is a tuple containing a list. This is a tuple containing a tuple. If I want to index this list now, I have to just call the index number. Okay, so if I just I call the index number, I will say my var top. My var top, I will call the index number 1. I run it. So when I call index number 1, look at what it's printing for me, 4,1, because this thing I seen as 1. All right, why is this seen as 1 too? But I can still index an item inside here. We call it stacked indexing. Also, you might say nested index or double indexing. You can also do that by calling, when you have to like a list inside a tuple or a tuple inside a tuple, you can call the inner tuple. You can get items from the inner tuple. How do you do that? You call the general tuple, then you call the index number of that list or that tuple inside of that nested tuple or nested list inside the main tuple. Then inside that list or tuple, it also has an index 0 or 1, depending on how long the list is inside. Then you call the item you want to get. Now, this was me calling the list 1, which is a tuple. Don't forget, I cannot change this information. Now, if I want to call the value now 4 inside this list. Now, first of all, I have to call the index number of the item in the tuple, which is this list 41. Then I'm going to put a square bracket and then call the index number of what I want. So I'll put 0. Now, when I run this, what is getting me? 4. So first of all, it's going to go through the first tuple, get the location of index number 1. Then inside the index number 1, it's going to get the location of 4 because they have multiple items. If this item was just 1, trust me, you cannot work like that. All right, but because it is multiple items, I can do this nested indexing, okay, or double indexing or stacked indexing, as people might call it. So that's how you index. Now let's say I want to get the indexing of this list. Now in the tuple, this list is index number 0, 1, 2. So I'll call this index number 2. That means go to index number 2, then fetch me the last item. Let me use negative indexing here. Minus, sorry, let me click. Minus 1. Oh, minus 1. So I want to get it. Watch. Minus 1. So what is it getting me? 2. All right. So first of all, it goes to the tuple, locates the index number 2, and then gets me the last item inside the nested list. All right, or list inside tuple. That's what it's getting me. So that's how you index anything that is nexted. Anything that is nexted, this is how you index it. If you want to get what is inside the nexted list or nexted tuple, this is how you index it. So I'm trying to get it for this. It's the same function, the same way I write this. It's the same way I'm going to use this. I'll just change the name, the variable. I'll just call the variable name to get it. Okay, guys. So that's all for list and tuple. Next class we'll be talking more on sets and dictionary. We'll cover that. So at this page, I want to take some questions. So firstly, I'm going to end. Let me end the recording so I can take questions. So if you have questions, please If you have questions, please, for the few times we have,